It is February 20th, 2026. At 4:15 UTC this morning, an alarm triggered inside the servers of the High-Energy Stereoscopic System HES in Namibia. Not a routine alert, not a false positive from a dead pixel on a sensor. A real alert, verified 3 times by 2 separate operators before being transmitted up the chain. The signal came from 3I Atlas, and that signal should not exist. Before we go any further, let's establish the baseline. Let's talk about what 3I Atlas is supposed to be, what every catalog entry, every initial classification, every press release said it was when it first appeared in our data. 3I Atlas was discovered on December 12, 2025 by the Atlas Telescope Network in Hawaii. The Asteroid Terrestrial Impact Last Alert System Atlas is one of the most sensitive sky survey programs ever built, designed specifically to detect fast-moving objects before they become a threat. When it picked up 3I Atlas, the object was already inside the outer reaches of the solar system, falling inward on a hyperbolic trajectory. Hyperbolic. That single word already separates 3I Atlas from most comets. A hyperbolic trajectory means the object is not gravitationally bound to our Sunday. It is a visitor, something that came from outside, from the vast interstellar medium between stars, and will leave again, never to return. We had seen this before. Oumuamua in 2017, Borisov in 2019. Both interstellar, both strange, both ultimately classified as natural objects despite the questions they raised. At discovery, 3I Atlas was classified as a long-period comet, a block of ice and rock, a dirty snowball, as the old model goes, falling inward from the cold void, warming as it approached the sun, sublimating gas and dust into a coma and tail. Standard, predictable, unremarkable. But on January 14, 2026, something changed. The trajectory shifted, not by a gravitational perturbation, no planet was close enough to account for it. Not by an impact, no flash, no debris cloud, no energy spike consistent with a collision. The object simply accelerated, spontaneously, as if something inside it had decided to push. Astronomers noted it. They filed reports. They proposed explanations: outgassing asymmetry, where venting gas acts as a weak thruster. It happens with comets. The numbers didn't quite fit, but the community logged it and moved on. Then this morning, at 4:15 UTC, HES detected something in the object's wake that made moving on impossible. Iron-60. Take a moment, pause here, because what I'm about to explain is the foundation of everything that follows. And if you don't understand why Iron-60 is impossible, none of the rest of this will hit the way it should. Iron-60 is a radioactive isotope of iron. Its atomic nucleus contains 26 protons and 34 neutrons, 2 more neutrons than stable iron, 5-8. That extra neutron load makes it unstable. It wants to decay. And it does, slowly, emitting gamma radiation as it converts into cobalt-60 and eventually nickel-60. The half-life of that process is 2.6 million years. Now, here is the critical point. Our solar system is 4.5 billion years old. Any Iron-60 that existed when the sun and planets formed has had 4.5 billion years to decay. Run the math. After 4.5 billion years, roughly 1,730 half-lives, the fraction of original Iron-60 remaining is so vanishingly small that no instrument on Earth or in orbit could detect it. It is, for all practical purposes, gone, extinct, a ghost. The only way to find fresh Iron-60 inches the universe today is to go looking near a supernova, a massive star that exploded recently within the last few million years, because the violence of that explosion is one of the only natural processes energetic enough to synthesize it in quantity. Alternatively, you could find it coming out of an artificial nuclear reactor, where engineers deliberately create unstable isotopes by bombarding stable elements with high-energy neutrons. Those are the two options: dying star or technology. This morning, 3I Atlas emitted 4,000 tons of it in a single burst. In observational science, a single detection means nothing. That is not cynicism, it is method. The entire architecture of modern physics is built on reproducibility, on independent confirmation, on the assumption that if something is real, multiple observers using different tools will see the same thing. So when Hess flagged the Iron-60 signature at 4:15 UTC, the immediate response was not alarm, it was scrutiny. I went through the raw telemetry myself. For 40 minutes, I worked through every plausible explanation for a false detection. Sensor saturation from a nearby bright source. Cosmic ray muons mimicking a gamma signature. A calibration drift in the photomultiplier tubes. A software artifact in the signal processing pipeline. Each hypothesis collapsed under examination. The data was clean. The calibration was nominal. The background subtraction was correct. Hess was seeing something real. At 2:45 UTC, roughly 30 minutes after the initial Hess detection, NASA's NuSTAR telescope was slewed to the coordinates of 3I Atlas. The Nuclear Spectroscopic Telescope Array is one of the most sensitive high-energy X-ray observatories ever placed in orbit. It does not see visible light. It sees the hard X-ray emissions produced by violent, high-temperature, high-energy astrophysical events, black hole accretion disks, neutron star surfaces, supernovae shock fronts, and the decay products of radioactive isotopes. NuSTAR confirmed the Iron-60 signature within minutes of acquiring the target. But NuSTAR did something Hess could not. It measured the thermal profile of the emission, the temperature of the material producing the signal. The readings were clear. The Iron-60 was hot, thermally excited. This was not cold material drifting passively through space, having traveled for millions of years since some long-dead explosion. The isotope was warm in a way consistent with recent energetic ejection from an internal source. Something inside 3I Atlas had produced it recently and expelled it outward with enough force to heat it measurably above the ambient temperature of interstellar material. At 3:12 UTC, ESA's Integral spacecraft achieved independent confirmation. Integral, the International Gamma Ray Astrophysics Laboratory, has been operating since 2002, cataloging gamma-ray sources across the sky with extraordinary precision. It was not pointed at 3I Atlas when the Hess alert went out. It was repositioned specifically to verify the detection. Using entirely different detector technology, different orbital geometry, different data pipeline, it measured the same spectral lines at the same energy levels with the same intensity profile. 3 independent observatories, 3 different agencies, 3 separate methodologies. One result: the Iron-60 was real, it was present in enormous quantity, and it was fresh. At that point, the anomaly crossed a threshold. It was no longer a potential instrument glitch to be investigated quietly. It was an astronomical fact, an observed, confirmed, multiply verified phenomenon that had no precedent in the entire history of solar system science. Now let's talk about why the mere existence of fresh Iron-60 near 3I Atlas is not just unusual. It is under any conventional model, impossible. Iron-60 functions as what astrophysicists call a cosmochronometer, a cosmic clock. The principle is straightforward and elegant. When a massive star explodes in a supernova, the energy of the explosion drives nucleosynthesis, the forge of new atomic nuclei from existing ones. Among the isotopes produced in large quantities during this violent process is iron-60. The moment the explosion occurs, the clock starts. The iron-60 begins its slow, steady decay into nickel-60, having every 2.6 million years with mathematical precision. By measuring the ratio of remaining iron-60 to accumulated nickel 60 inches, a sample of material, you can calculate backward to determine when that supernova occurred. It is the same conceptual logic as carbon-14 dating, but operating on timescales millions of times longer. And it is extraordinarily precise. At 5:42 UTC, NASA's Chandra X-ray Observatory, the most sensitive X-ray telescope ever built, analyzed the X-ray fluorescence spectrum of the deposited cloud. Chandra can resolve the emission lines of individual elements with enough precision to identify isotopic ratios. It measured the iron-60 to nickel-60 ratio in the material ejected by 3I Atlas. The ratio was close to 1:1. Let that number settle for a moment because it breaks the timeline of everything we know. A 1:1 ratio means that approximately half of the original iron-60 has decayed. That translates directly to an age of roughly one half-life, approximately 2.6 million years or less. In the context of a universe that is 13.8 billion years old and a solar system that is 4.5 billion years old, 2.6 million years is not just recent, it is extraordinarily recent. Cosmologically, it is the day before yesterday. Here is the problem. We have reconstructed the orbital history of 3I Atlas using every available measurement, its current position, its velocity vector, its deceleration from interaction with the interstellar medium. We have traced its path backward through space for tens of millions of years. That trajectory does not come anywhere near a known supernova remnant. It does not pass through any region of active star formation where massive stars live and die. It has spent its entire reconstructible history traveling through the cold, empty interstellar void, far from anything capable of producing fresh iron-60. And even if we invented a phantom supernova to solve the origin problem, we would still face the accumulation problem. The quantity of iron-60 detected 4,000 tons in a single emission event is not consistent with passive collection. A comet traveling through the diffuse remnants of a supernova would accumulate far, far less than this over millions of years. You do not accidentally pick up a mountain of specific radioactive isotopes by drifting through the void. The concentration is too high, the specificity is too precise, the quantity is too large. We are left with two interpretive options, and both of them are extraordinary. Option 1. 3I Atlas encountered an invisible, undetected, uncatalogued supernova remnant at some point in its journey, accumulated an impossibly concentrated load of fresh iron-60, preserved it in a configuration that prevented normal decay-driven dispersal for millions of years, and then released all of it in a single coherent burst at precisely the moment it reached 1.4 astronomical units from our Sunday. Every step of this sequence is individually implausible. Together, they constitute a scenario so unlikely that assigning a probability to it feels almost dishonest. Option 2, the iron iron-60 was not collected. It was manufactured. Something inside 3I Atlas is running a process that synthesizes iron-60 from stable precursor elements. That process requires a continuous input of high-energy neutrons. It requires thermal management. It requires engineering. Let's add another layer. Because the iron-60 detection, as extraordinary as it is, does not exist in isolation. It is one data point in a converging pattern that began building before this morning. On February 19, 2026, at 14 UTC, more than 14 hours before the iron-60 detection, the Solar Dynamics Observatory detected an anomaly in the solar wind as 3I Atlas moved through it. The solar wind is a continuous stream of charged particles, mostly protons and electrons, flowing outward from the Sun at speeds between 400 and 800 kilometers per second. When this plasma flow encounters an obstacle, it creates a bow shock, a standing wave of compressed plasma upstream of the object, similar to the wave that forms in front of a boat moving through water. The size and shape of a bow shock depends on the size of the obstacle and, critically, on whether the obstacle has a magnetic field. A strong magnetic field acts like an invisible shield, deflecting the incoming plasma before it reaches the physical surface of the object. The larger the magnetic field, the larger the bow shock. The bow shock created by 3I Atlas was 40% larger than its physical size would predict. That discrepancy has a clear implication. 3I Atlas has a magnetic field and a significant one. Comets do not have magnetic fields. This is not a minor oversight in our models. It is a fundamental property of what comets are. A magnetic field requires a dynamo, a self-sustaining electromagnetic generator driven by the motion of conductive fluid through a pre-existing magnetic field. The interiors of comets are not composed of molten conductive metal. They are ice, dust, and rock. Cold, rigid, inert. No dynamo, no magnetic field. The only natural objects in our solar system with intrinsic magnetic fields are the rocky planets with molten metal cores, Earth, Mercury, and the gas giants. Even among those, Earth's magnetic field creates a magnetosphere that deflects the solar wind at a scale proportional to the planet's size. 3I Atlas is not a planet. It should not have a magnetosphere, but it does. And when you place a powerful anomalous magnetic field alongside the sudden ejection of fresh, thermally excited radioactive isotopes, you are no longer looking at a collection of unrelated quirks. You are looking at a signature. Think about this analogy carefully, because it is more than illustrative, it is structurally accurate. If you were observing a nuclear-powered submarine from orbit, what would you see? Not the reactor itself, not the fuel rods, not the coolant loops. What you would see is a thermal signature in the water around it. You would see the magnetic disturbance created by its hull, its electrical systems, its shielded core. And if it flushed its primary cooling system, purging radioactive coolant water in a maintenance cycle, you might briefly detect a plume of specific isotopes trailing behind it in the wake. The observational profile of 3I Atlas on February 20th, 2026 matches that description with a precision that should make any physicist profoundly uncomfortable. Iron-60 is a gamma emitter. As it decays through its chain iron-60 to cobalt, 60 to nickel, 60, it releases gamma-ray photons at characteristic energies. Specifically, 1.17 megaelectron volts and 1.33 megaelectron volts. These values are not approximate. They are fixed by quantum mechanics with extraordinary precision, and and they serve as an unmistakable spectral fingerprint, a radioactive barcode that no other isotope produces at exactly those energies. At 6 UTC, NASA's Fermi Gamma Ray Space Telescope, designed to survey the entire sky for gamma ray sources ranging from pulsars to gamma ray bursts, detected a pulse at exactly those energy levels, originating from the position of 3I Atlas. This alone would be significant but not surprising, given what Hess, NuSTAR, and Integral had already confirmed. If Iron-60 is present, you expect gamma emissions at 1.17 and 1.33 MeV. What you do not expect is what Fermi measured next. In nuclear physics, radioactive decay is isotropic. This is not a simplification or an approximation, it is a fundamental consequence of quantum mechanics. A decaying atomic nucleus has no preferred direction. It has no internal compass. The gamma photons it emits travel outward equally in all directions, filling a sphere of radiation centered on the source. This is as basic and inviolable as physics gets at the nuclear scale. The gamma emission from 3I Atlas was not isotropic. Fermi's data showed the signal concentrated within a cone of approximately 3 degrees. A tight, focused beam of gamma radiation pointed directly away from the sun along the object's outbound trajectory vector. 3 degrees. For reference, the full moon subtends about half a degree as seen from Earth. A 3-degree cone is narrow, deliberately narrow, and it was aimed. Directed gamma ray emission at nuclear decay energies requires a physical structure that channels the radiation. In engineering terms, this is called a collimator, a device made of dense, radiation-absorbing material with a narrow aperture used to shape a beam from an otherwise isotropic source. Medical PET scanners use them. Industrial radiography systems use them. Research reactors use them. No comet has one. No comet could have one. We have observed more than 4,000 comets in modern astronomy. We have performed detailed spectroscopic analysis on hundreds of them. We have studied both prior interstellar objects, Oumuamua and Borisov, with every available instrument. Not one of them has ever produced a directed, collimated emission of fresh radioactive isotopes at nuclear decay energies. Not one. Ever. 3I Atlas did it this morning. There is one more data point that has received less attention than the isotope detection, but which independently corroborates the overall picture in a way that is difficult to explain away. On February 18, 2026, 2 days before the Iron-60 event, ground-based photometric monitoring of 3I Atlas detected a 0.04% increase in the object's rotation rate. The object was spinning slightly faster than the day before. In isolation, this is unusual but not unheard of. Asymmetric outgassing, where venting material from one side of a rotating body exerts a net torque, can gradually alter a comet's spin. It is a known phenomenon called the Yorp effect and its variants, and it operates slowly over long periods. But then this morning, at the precise moment the Iron-60 plume was released, within the same UTC minute the rotation rate stabilized. The acceleration stopped instantly. The correlation between the emission event and the rotational change is exact. Natural processes do not work this way. If outgassing were responsible for the spin-up, the release of material would continue or increase the effect. It would not abruptly terminate it. The sudden cessation of rotational acceleration at the exact moment of the isotope release implies that both events share a common cause. Something inside the object changed its behavior in a coordinated way, affecting both the emission of radioactive material and the object's angular momentum simultaneously. And then, 30 minutes after the Iron-60 Iron-60 cloud was deposited into space, 3I Atlas went dark. Not completely, but for 18 seconds, its measured brightness dropped measurably before returning to full luminosity. Rocks do not blink. Comets do not blink. Active venting produces diffuse scattering that increases apparent brightness, not decreases it. A controlled, temporary reduction in luminosity, followed by immediate restoration, has no natural explanation in the context of a small body. At 7:15 UTC, the DSS 4-3 antenna of NASA's Deep Space Network in Canberra, Australia, recorded the event that removed the final ambiguity from this sequence. The Iron-60 cloud stopped. I want to explain this carefully because this is the single most physically extraordinary observation of the entire event sequence, and it requires understanding a basic law of physics that most people learned and then never thought about again. Newton's first law of motion states that an object in motion remains in motion at constant velocity unless acted upon by an external force. In space, where there is no air resistance and gravity is weak at the relevant distances, this law operates with almost perfect precision. When a comet sheds material ice sublimating from surface heating, dust escaping from gas jets, that material inherits the velocity of the parent body at the moment of release. It keeps moving. It may slow slightly due to solar radiation pressure. It may be deflected slightly by the solar wind, but it does not stop. Comet tails demonstrate this principle visually. The debris and gas released by a comet form a tail that points away from the sun, not backward along the comet's path, but anti-sunward, shaped by radiation pressure. The material in a comet's tail is still moving through space. It is simply being pushed sideways by photon pressure. It never stops. 3I Atlas was traveling at 26 kilometers per second when it released the Iron-60 cloud. Within 4 minutes of release, that cloud had decelerated to a near halt relative to the solar wind. The separation between the cloud and the main body grew at a rate completely inconsistent with passive emission. An object released from a body moving at 26 kilometers per second retains that velocity. For the cloud to decelerate to near zero in 4 minutes, it must have been ejected with a velocity vector opposite to the direction of travel, essentially launched backward with enough force to cancel its inherited momentum entirely. Think about what that requires. 3. Atlas is moving at 26,000 meters per second. To eject material that ends up stationary in the solar wind reference frame, you must launch that material rearward at approximately 26,000 meters per second relative to the object. That is not outgassing. That is not sublimation. That is a rocket burn. That is a precisely calculated expulsion of mass at a specific velocity in a specific direction to achieve a specific outcome. The probability that a natural gas pocket inside a comet could explode with exactly the right energy, in exactly the right direction, to cancel its momentum to within the measurement precision observed, is approximately 1 inch 14 billion. That number is not hyperbole. It is a straightforward calculation from the observed deceleration profile and the constraints of realistic cometary gas dynamics. If this is artificial, the interpretation is straightforward. 3I Atlas executed a reactor purge. It ejected its radioactive waste products rearward with calculated velocity, clearing its operational envelope before the next phase of its mission. This is a standard procedure in nuclear propulsion engineering. Any spacecraft using nuclear thermal propulsion or nuclear pulse propulsion must periodically vent decay products, and doing so rearward prevents contamination of the primary vehicle. and immediately afterward, at 7:30 UTC, within minutes of the cloud separation, the main body of 3I Atlas accelerated. Shed mass, gain speed. This is conservation of momentum applied deliberately. This is thrust management. In 40 years of cataloging comets, interplanetary objects, and interstellar visitors, we have never observed this sequence in a naturally occurring body. Not once. The radioactive debris cloud is now drifting in the plane of Earth's orbit, pushed by the solar wind toward our path around the Sunday. Let's now lay every confirmed observation side by side and look at what they form together. December 12, 2025. 3I Atlas discovered on a hyperbolic trajectory, interstellar origin confirmed. January 14, 2026. Unexplained spontaneous acceleration inconsistent with known outgassing models. February 18, 2026. Rotation rate increases by 0.04% with no identified cause. February 19, 2026. 14 UTC. Solar Dynamics Observatory measures a magnetic bow shock 40% larger than the object's physical size would predict, indicating an anomalous magnetic field. February 20th, 2026, 4:15 UTC. HESS detects Iron-60 inches, the object's wake, an isotope that should not exist in the inner solar system at any detectable concentration. 2:45 UTC. New star confirms detection and measures thermal excitation of the material, indicating fresh, energetic ejection from an interior source. 3:12 UTC. Integral independently confirms at identical spectral lines. 5:42 UTC. Chandra measures iron, 6:0 to nickel, 6:0 ratio near 1:1, indicating synthesis within the last few million years impossible given the object's reconstructed trajectory. 6 UTC. Fermi detects directed gamma emission within a 3-degree cone, pointed anti-sunward, physically impossible from isotropic radioactive decay. 7:15 UTC. DSS 4-3 tracks the iron, 6-0 cloud decelerating to near halt within 4 minutes of release, a retro thrust vector of 26 kilometers per second, inconsistent with any known natural ejection process. 7:30 UTC. Main body of 3I Atlas accelerates immediately following mass ejection. These are not isolated anomalies. They are not unrelated data points scattered across an otherwise normal observation set. They form a sequential, internally consistent narrative, each event following logically from the previous one, each data point reinforcing the others. 2 frameworks exist for interpreting this data. Framework 1. We are witnessing a previously unknown class of cometary behavior. An interstellar object, through a combination of exotic composition and unusual internal chemistry, has managed to concentrate fresh radioactive isotopes from an unidentified source, preserve them in a thermally stable configuration for millions of years, generate an anomalous magnetic field through an unknown mechanism, and then release the isotopes in a collimated beam while simultaneously executing a momentum-canceling ejection maneuver, all while maintaining correlated changes in its rotational state. This framework is not logically impossible. It is, however, requiring us to add unknown mechanism upon unknown mechanism, stacking improbabilities like a house of cards. Each anomaly demands its own exotic explanation. None of those explanations exist in our current models. And crucially, accepting this framework means accepting that all of these independent anomalies coincidentally align into a pattern that is indistinguishable from the behavior of an engineered system. That is a very uncomfortable coincidence. Framework 2. 3I Atlas is an artificial object. It is using nuclear propulsion of some kind, a system that produces Iron-60 as a byproduct of its power generation process. The magnetic field is the signature of its shielded power core and electrical systems. The directed gamma emission is the output of a collimated waste radiation management system. The retroejection of the debris cloud is a routine purge cycle. The subsequent acceleration is the main drive re-engaging after the purge. The rotation anomaly and the 1/8 second dimming are consistent with an internal mechanical event, something moving, reorienting, cycling inside the object's body. Under this framework, every single observation has a clear, internally consistent explanation. No new physics required, no exotic unknowns invoked. Just the straightforward application of nuclear engineering principles to an object we mistook for a comet. The radioactive cloud it left behind is drifting through Earth's orbital plane. It will not reach Earth's surface. The quantity of Iron-60 dispersed across the volume of space represents negligible radiation exposure at orbital distances. But its position is not without meaning. It marks a waypoint, a trail, evidence that something passed through here and left its waste behind, the way a ship leaves a wake. Right now, as you watch this, the instruments are still running. The Chandra X-ray Observatory is tracking the thermal evolution of the main body, watching for any additional heat signatures that would indicate continued internal activity. If the nuclear process that generated the Iron-60 is ongoing, Chandra should detect it. The Deep Space Network is monitoring the object's velocity and trajectory with millimeter-per-second precision. If 3I Atlas executes another course correction in the next 12 hours, if it changes direction again in a way that cannot be explained by gravitational mechanics, the case for Framework 2 becomes, in scientific terms, essentially unassailable. Fermi remains pointed at the object, watching for additional directed gamma emissions. If the beam appears again, we will have confirmed that the first occurrence was not an aberration. And Hess in Namibia continues its vigil, watching for the next isotope release, because if this was a maintenance purge, there may be more to come. The data stream is live. Every hour brings new measurements. The telescopes are not sleeping tonight. Whatever 3I Atlas truly is an unprecedented natural phenomenon, a cosmological mystery beyond our current models, or something else entirely, the answer is coming through the instruments in real time, one measurement at a time, building toward a conclusion that we are not yet equipped to ignore. The physics does not lie. The instruments do not fabricate correlations this precise. The numbers are what they are. And the numbers say that 3I Atlas is unlike anything we have ever seen. T-12 hours. The detectors are live. We are about to find out.